Hello students, welcome to the lecture on work measurement, and after this lecture we will be able to learn the following objectives. Explain purpose of work measurement, describe time study method, explain principles and calculation methods of work sampling. Let's start with the concept of work measurement. Work measurement is a series of techniques employed to evaluate the time needed for completion of a task by an average human worker. This evaluated time is called the standard time of the task. The standard time serves as a benchmark for productivity. Standard time is the time required by qualified and well-trained person working at a normal pace to do a specified task. Any worker who exceeds the standard time set for a particular task is said to be working slowly. Purpose of work measurement: to reveal the nature and extent of ineffective time from whatever cause, so that action can be taken to eliminate it, and then to set standards of performance that are attainable only if all avoidable ineffective time is eliminated and work is performed by the best method available. Operations managers are interested in how long it takes to create an output or outcome, or equivalently, how much can be produced over a certain length of time. Work measurement is a systematic procedure for the analysis of work and determination of times required to perform key tasks in processes. Work measurement leads to the development of labor and equipment, time standards that are used for estimating workforce and equipment capacity, establishing budgets, determining what new work procedures will cost, evaluating time and cost trade-offs among process design alternatives, establishing wage incentive systems, monitoring and evaluating employee performance and productivity, and providing accurate information for scheduling and sequencing. Without accurate time standards, it is impossible to perform these tasks. For example, the process of assembly line balancing discussed in requires accurate estimates of the standard time required to perform each task or work activity. Standard times are management's anchor in an uncertain operating environment. To establish usable standards, work tasks and activities must be carefully defined and studied. Thus, job and process analysis should precede work measurement. How long it takes to perform a task depends on the worker's pace, operating conditions, and work method. Normal time is the expected time required to perform some work activity at a normal pace under normal operating conditions and using a prescribed method. By a normal pace, we mean a pace that can be consistently performed by the average employee without undue fatigue under normal operating conditions. The prescribed method to perform a task is usually developed by industrial engineers who identify the most efficient and safest procedure. Normal times must also be adjusted for personal time and unavoidable delays. Allowances include time for labor fatigue and personal needs, equipment breakdowns, rest periods, information delays, and so on. The performance rating factor and allowance factor are based on human judgments, and therefore the procedure for establishing standard times must include audits, third-party reviews, and extensive training and retraining of work-study analysts to keep them properly calibrated. Videotapes of employee work activities are often used to train work-study analysts. Uses of work management: to compare the efficiency of alternative methods. Other conditions being equal, the method which takes the least time will be the best method. To balance the work of members of teams in association with the multiple activity charts so that as far as possible each member has tasks taking an equal time. To determine, in association with man and machine multiply activity charts, the number of machines a worker can run. Applications. Standard times for different operations in industry are useful for several applications like estimating material machinery and equipment requirements, estimating the production cost per unit as an input to preparation of budgets, determination of selling price, make or buy decision, estimating manpower requirements, estimating delivery schedules and planning the work.
An important part of process analysis is the measurement of the work to be performed in a process. Information such as the number of seconds taken to carry out each step, or the number of repetitions that can be performed per hour, etc., are important pieces of information that need to be a part of the process documentation. More importantly, these data are very relevant when we are thinking about improving the process. One way to measure work is to simply take a stopwatch and time an activity over several iterations. This method is called time study. Of course, we need to be timing iterations that are representative of the activity in general, as determined by a trained analyst. The time standard that we develop is particularly useful to analyze linear flow processes. The time standard can also be used to estimate the labor hours it will take to complete a customer order, set the price we should charge our customer, forecast the time required to complete the order, etc. Let us take a look at this example. Here is an activity that we studied for 40 iterations. To calculate a time standard for this activity, we first average all our observations. We are told that the employee we observed has a 95% performance rating. So, if a 95% employee took this many seconds, an average employee, that is a 100% employee, will take less time than that. We can get an average employee's time by taking 95% of the observed employee's time, which we call as the normal time. Any employee performing the above activity needs breaks every once in a while. As well, the employee's speed is likely to be affected by fatigue and other such factors. To set a time standard for this activity, we need to make allowance for these factors. We are told that allowances are 15% of the normal time. Adding this 15% brings our time standard to 115% of the normal time. Notice that we are trying to maintain a high level of detail in terms of the number of decimal points. Let us say we are trying to estimate the time it will take to produce 5,000 widgets. Any rounding error in the time standard for a single iteration will be multiplied 5,000 times. Now suppose we have a flexible flow process and are doing different things for different customers. Even though the orders are different from day to day, the orders can be broken up into elements that are pretty standard. For each of these elements, we can maintain a database of time standards. Whenever an order comes in, we can examine the different elements it is made up of, look up our database, and set a time standard. This method is called the elemental standard data approach. Another method of setting a time standard without taking out a stopwatch every time is by using a predetermined data approach. Like a time study, this method is also useful for a linear flow process. Here, rather than timing the process steps, we break up the steps into micro-level activities. For each of these micro motions, we refer to standard tables to estimate the time taken. I walk 3 feet. There's a standard for that. It takes so many microseconds. I reach out 2 feet. There's a standard for that. It takes so many microseconds. I pick up a 5-pound weight. There's a standard for that. It takes so many microseconds. And so on. I simply add up the time taken for all the micro motions in my process. Another kind of work measurement applies to a situation where an employee is engaged in a variety of activities throughout the workday. Consider an employee working at a retail store where customers expect a lot of hand-holding, and each customer has widely varying needs. It does not make sense to take a stopwatch and measure the time taken to serve an average customer. At times during the day, there are no customers present. At those times, the employee is asked to restock the shelves, reshelve the strewn items, do some work in the back, etc., until the next customer shows up. Although we don't want to set a time standard for these activities, we want to measure what proportion of the employee's time is spent on what kind of activity. For that, we use a work sampling study. Consider the example of our store employee. We take random observations over a period of time. Even the number of observations on each day is randomized. Using the information we have collected, we can determine that about 30% of the employee's time is spent attending to customers. About 29% restocking shelves. About 20% reshelving strewn items. And about 21% is idle time. Whenever we are measuring work or trying to set a time standard, we need to take into account the fact that, with repetition, people and processes get better at doing things. This is called the learning effect or the experience effect. Generally speaking, the more complex the activity, the greater the opportunity for learning and improvement. With a less complex activity, although the learning rate might not be high, the number of iterations is likely to be high, such as with a line flow situation. Either way, it becomes important to correctly estimate the learning rate. Say our company is bidding on an order of 50 airplanes for an airline. Given the complexity of the process, we can expect a significant learning effect. If we bid based on the labor hours it took for our prototype, our bid will come in extremely high. On the other hand, if we estimate the learning effect very aggressively, we will end up with a whopping loss. Similarly, suppose our company is introducing a new car model. We anticipate that we will sell 10,000 units of this model over the coming year. We will need to determine our pricing based not on the first several production runs, but based on an estimate of the long-term process costs. Our first several production runs are essentially going to sell at below cost. Consider this example. The roofing contractor estimates that the first roof will take 40 hours. Given a 95% learning rate, we can estimate that the second roof will take 40 hours times 95%, or 38 hours. The learning effect works like this. Every time the cumulative number of iterations doubles, we can multiply the time estimate by 95%. Therefore, our fourth roof will take 95% of 38 hours, or 36.1 hours. Continuing in this manner, we can estimate that the eighth roof will take 95% of 36.1 hours, or 34.3 hours. The 16th roof will take 32.58 hours. The 32nd roof will take 30.95 hours. And the 64th roof will take 29.4 hours. To estimate the time taken for the third roof, the fifth roof, etc., as well as the total time for a particular number of roofs, such as all 100 roofs, there are standard tables available for different learning rates that we can use.
Now we will discuss the work measurement techniques. The work under question may be repetitive or non-repetitive type. In repetitive operations, the elements of operations will repeat many times during the study. In non-repetitive works, work cycle is hardly repeated. The example of such work are maintenance work and construction work. depending on the type of work means repetitive or non-repetitive, proper method of work measurement is selected. Basically, there are 8 methods of work measurement. They are stopwatch time study, synthesis, predetermined motion time system (PMTS), analytical estimating, comparative estimating, activity sampling, time study, activity sampling and rated activity sampling, synthesis from standard data. Stopwatch time study. Stopwatch time study makes direct observations by means of a simple stopwatch measuring generally to the precision of 0.01 minute. The observation equipment consists of the stopwatch, the recording board, the observation sheet and a pencil. The steps involved in such a study are: subdivide the jobs into observable and distinct elements. Choose acceptable operators for study. Make direct observations of the work elements while the operator is actually performing the job and record the time of each element. Make a statistically adequate number of repeated measurements and record the time of each element. Make a statistically adequate number of repeated measurements and record each time. Performance rate each element and record. The key step in stopwatch time study is that of subdividing the job into component element. One should take care that the elements are distinct or well defined and therefore amenable to repeated measurements. Also, the elements should be as short as possible without losing accuracy of measurement. The practical minimum is generally 0.02 or 0.03 minute, the time required to read and record being 0.027 minutes or 45 TMU time measurement unit. The following are uses of this breakdown into elements. It helps in separate performance rating of each of the job elements instead of performance rating the whole job, which may lead to much error in the time standard. If a job method changes in terms of only 1 or 2 elements, the revised time standard can be easily established in the future. Unnecessary time studies are therefore eliminated. Standards for similar or related jobs can also be easily established. It highlights the work element which consumes excessive time, and this can then be subjected to a critical examination to eliminate, substitute the element. Elements with large variation in time can be examined for necessary changes in the job design or method. It highlights the inconsistency in working conditions. Synthesis. This synthesis technique is used where standard time is computed by adding various elemental times which constitute the work. Standard data is available for most of the known elemental operations such as for preparatory, setting, manipulating, removing, clearing, tool positioning, holding and tightening. The data should be stored in a library in such a manner for easy reference when required for estimating purpose. These standards cannot be transferred to other factories as they refer to the particular conditions prevailing in a specific workshop at a given factory. Predetermined motion time system (PMTS). It is defined as a work measurement technique by which normal times are established for basic human motion, and these time values are used to build up the time for a job at a defined level of performance. It is a work measurement technique that involves observing through a job, recording job elements, recording pre-established motion units, and calculating a performance standard. PMTS is an improvement over motion study because besides affording detailed analysis of the motion, it makes it possible to set a measure of the time that a series of motion ought to take. Following are the steps involved in PMTS. Observe the job if it is not being performed. It is best to observe under typical conditions, typical machine, material and worker. Divide the job elements. Do not be concerned about timing them, just thoroughly document all motions performed by the worker. From a table of predetermined time standards, record the standard for each motion units. Find the sum of the standards for all motions. Estimate an allowance for personal time, delays and fatigue, and add of the sum of standards. Analytical estimating. This technique is used to determine the time values for jobs having long and non-repetitive operation. The time values are determined by using synthetic data or on the basis of past experience of the work study when no synthetic of standard data is available. It is essential that the estimator must have adequate experience of estimating, motion study, time study, and the use of standard data. Comparative estimating. A work measurement technique in which the time for a job is evaluated by comparing the work in it with the work in a series of similar jobs, benchmarks, the work content of which has been measured. When we want to prescribe time for a new job, it is compared with the benchmark jobs and a judgment is made as to which band of jobs it most nearly compares with. It is then judged to be of this band and the appropriate work value from the band is taken as being the work value applicable. Now moving on to the next topic, we will discuss time study. Direct time study, as its name suggests, is the direct measurement of the time taken by an operator or worker to complete a certain task. It involves the subdivision of the entire task into the various work elements that it is composed of and measuring the time taken to accomplish each work element. The total operation time is then calculated as the sum of the individual work element times. A rating is then given by the evaluator, which is used to calculate the normal time that is required for completion of the task. Normal time is defined as the time required accomplishing a certain task by an average worker working at a normal pace but without any allowances. It represents the time taken to complete the task alone. The standard time for the operation is then computed by adding any allowances as required to the normal time. In this way, we can compute the maximum allowable time for completion of an operation beyond which the worker is said to be working at a lower than normal pace. Selection of the job for the time study is an important initial step. There are various reasons why a certain job or operation might need a time study performed on it. Some of them are: the job in question is a new one for which a time standard has not yet been determined. There has been a change in the method used for the operation of materials which could affect the time standard. A particular operation appears to be a bottleneck holding up several other operations because it is taking too much time. The cost of a particular job appears to be excessive, and as study is needed to determine if the method is inefficient. The worker factor. Employees present one of the biggest challenges with direct time study. One of the most important steps before performing a time study is obtaining the consent of the foreman and or workers involved in this operation. This is important since the purpose of a time study is not fairly obvious at first. The entire objective of the time study could be misunderstood unless it is carefully explained to everyone. Anyone performing a direct time study must first obtain consent from the foremen and or the workers and explain to them clearly the objective of the time study, what the process would involve, and seek their consent before going on with the process. The person performing the study should position himself appropriately for performing the time study. Allowances and time standard. Normal time is calculated as the product of observed time and the rating. This time represents the amount of time taken by an average worker working at a normal place to complete the task. However, this does not account for various delays such as personal needs of the worker, fatigue, and possible delays in the process due to breakdowns, etc. To compensate for such delays, allowances are calculated and added to the normal time to give what is known as the standard time, which represents the time required for completion of the task inclusive of delays. Allowances are applied as a percentage of normal time. The standard time for the operation is determined as the sum of the normal time and allowances obtained from the product of normal time and the percentage of allowance. Time study equipment. The following equipments are needed for time study work: timing device, time study observation sheet, time study observation board. Other equipment: timing device. The stopwatches and the electronic timer are the most widely used timing devices used for time study. The two perform the same function with the difference that electronics timer can measure time to the second or third decimal of a second and can keep a large volume of time data in memory. Time study observation sheet. It is a printed form with space provided for noting down the necessary information about the operation being studied, like name of operation, drawing number, name of the operator, name of time study person, and the date and place of study. Spaces are provided in the form for writing detailed description of the process element-wise, recording stopwatch readings for each element of the process, performance ratings of the operator, and computation. Shows a typical time study observation sheet. Time study board. It is a lightweight board used for holding the observation sheet and stopwatch in position. It is of size slightly larger than that of observation sheet used. Generally, the watch is mounted at the center of the top edge or as shown in the upper right hand corner of the board. The board has a clamp to hold the observation sheet. During the time study, the board is held against the body and the upper left arm by the time study person in such a way that the watch could be operated by the thumb, index finger of the left hand. Watch readings are recorded on the observation sheet by the right hand. Normal performance and rating. There is no universal concept of normal performance. However, it is generally defined as the working rate of an average qualified worker working under capable supervision but not under any incentive wage payment scheme. This rate of working is characterized by the fairly steady exertion of reasonable effort and can be maintained day after day without undue physical or mental fatigue. The level of normal performance differs considerably from one company to another. What company A calls 100% performance, company B may call 80%, and company C may call 125%, and so on. It is important to understand that the level that a company selects for normal performance is not critical, but maintaining that level uniform among time study person and constant with the passage of time within the company is extremely important. Issues with time study. Time study has many latent benefits that come with it. One such benefit is that it is highly versatile and can be easily applied to any operation. However, there are many disadvantages to applying the time study method for work measurement. Time study is a highly tedious process from the start to the end. It involves a comprehensive study of the process and needs to be performed again for a change in process. Taking measurements of the operator is also highly tedious, especially when the sample size needed is fairly large. This process cannot be applied to situations when the job cycle time is very high. It can also not be applied to jobs that are highly complex and have several work elements, since it becomes fairly cumbersome to note element times for such processes. Advantages of time study. Direct time study is fairly versatile, since it only involves the use of a time measuring device such as a stopwatch, and time is measured directly. A description is provided of the method along with a sketch. This helps understand the conditions and nature of the task being performed, even in the future when referencing past time study records. Direct time study is applicable to a single subject, unlike work sampling, which is better suited for groups of subjects. Direct time study provides a greater detail about the capabilities of individual workers. It is a highly efficient system through which needed information can be obtained in less time and at a lower cost compared to other methods of work measurement. It is also known as activity sampling, ratio delay study, random observations study, snap reading method, and observation ratio study. It is based on the laws of probability. A sample taken at random from a large group tends to have the same pattern of distribution as the large group or universe. Sampling procedure. Step 1. Define the problem. Describe the job for which the standard time is to be determined. Unambiguously state and discriminate between the two classes of activities of operator on the job. What are the activities of job with which, if operator is found engaged, would entitle him to be in working state? This would imply that when operator will be found engaged in any activity other than those would entitle him to be in not working state. Step 2. Design the sampling plan. Estimate satisfactory number of observations to be made. Decide on the period of study, example, 2 days, 1 week, etc. Random observations. The next step in work sampling is to take observations. An important factor is that the observations must be random. This can be ensured by using a table of random numbers to determine times for observation taking. Advantages of work sampling. It is easier to measure processes that have long cycle times or are costly to measure by work sampling. A study can be made of several operators simultaneously using work sampling. Time study, however, requires an analyst for each operator analyzed. Disadvantages of work sampling. Work sampling is not economical for studying a single operator or machine or studying operations or machines spread out over large areas. Time study permits a finer breakdown of activities and delays than is possible with work sampling. Work sampling does not provide as much detailed information as is available from a time study. Now, in the end, let us summarize what we have learnt in this lecture. Work measurement is a series of techniques employed to evaluate the time needed for completion of a task by an average human worker. This synthetic technique is used where standard time is computed by adding various elemental times which constitutes the work. Direct time study, as its name suggests, is the direct measurement of the time taken by an operator or worker to complete a certain task. Ratings help in determining the normal time for an operation, and they represent the rate at which a worker is working. Work sampling is not economical for studying a single operator or machine or studying operators or machines spread out over large areas.